Elimination is another method of solving a system of linear equations. So an elimination method looks like multiplying in both one or both of the equations first and then adding the equations up in order to eliminate a variable. So, and you're still going to end up doing substitution at the end. So to do elimination, what you want to do is you want to see if I add these equations up, will I be able to eliminate a variable? So notice how both of these equations are in standard form. If I'm using elimination, I like to write them in standard form. So if I add up the x's, I don't eliminate the variables, but if I add up the y's, I will eliminate the y variable. So then I'm going to be left with 5x plus 3x is 8x, and negative 48 plus 32 is positive or negative 16. So if I divide both sides by 8, I'm going to get x equals negative 2. Now it turns into a substitution problem because you're going to take this negative 2 and you're going to substitute it in for x in either the first equation or the second equation. So I'm going to do that over here. So 5 times negative 2 minus 6y equals 32. Negative 10 minus 6y equals 32. So I'm going to add 10 to each side. Negative 6y equals 42. Y equals negative 7. So then my ordered pair is going to be negative 2, negative 7. That's my answer. For the second one, I'm going to look at, okay, if I add these two equations together, I will be able to eliminate the x, and I'll be able to eliminate the y. So here's what happens. If I add up these two, I'm going to get 0. If I add up these two, I'm going to get 0. And then if I add up the constants, I'm going to get 16. So then I'm left with 0 equals 16, and my variables dropped out. So if your variables dropped out and this is a false statement, what that means is there's going to be no solution. So these are going to be parallel lines that never intersect if you looked at the graphs. They don't have any points in common. So now, move this over here. I'm going to solve these by elimination. So if I add up and I'm not able to eliminate, so if I add these, nothing's going to eliminate if I add these up. So what do I actually have to do is I have to manipulate these equations. So I can try to either eliminate the x's or the y's. It doesn't matter. But what I'm going to do, and I'm going to eliminate the x's. So in order to eliminate the x's, I have a 10x, and I'm going to want to make this to be opposite. So I'm going to change this to a negative 10x. So in order to change this to a negative 10, I multiply this by 5, and I have to make sure I multiply both sides of the equation in order to keep it balanced. So I'm going to rewrite that in red what this new equation is going to be. It's going to be negative 10x minus 25y equals 22 times 5, which is 110. So now I have these two equations right here that I can use elimination for. So if I add these two up, this is going to cancel out, so I'm going to get negative 22y equals 132. So if I divide both sides by 20 or negative 22, I get y equals negative 6. So once I have y equals negative 6, I can take this and I can plug it back in for y in either one of the equations. So I'm going to plug it back into this one. So I'd always plug it back into the original equation. So I have 10x plus 3y, which is negative 6, equals 22. 10x minus 18 equals 22. 10x equals 40, so x has to be 10, or 4. So my ordered pair, my answer is going to be 4, negative 6. Over here, if I add these up, they don't eliminate. They need to be opposites. So I'm going to add up, I want to change these to be opposites, so that means that all I need to do is make one of these equations opposite. So I'm going to take this top line and rewrite it multiplying through both sides by negative 1. So it's negative 6x minus 3y, and don't forget to divide the constant by negative 1, 12. Now I can eliminate by adding these up. So if I add up these two equations, the x's cancel out, and I get 2y's minus 3y's, which is negative y, equals 12 plus negative 4 is 8, which means y has to equal negative 8. So I'm going to use substitution and plug those back in here. So 6 plus 3 times negative 8 equals negative 12. 6x minus 24 equals negative 12. So I add 24. So 6x equals 12. X equals 2. So my ordered pair answer is going to be 2, negative 8. Okay, down here, if I look at number 3, I can't eliminate those by adding up. So if I add up these two, I'll get 11x. That won't eliminate. If I add up these two, it won't eliminate. So what I'm going to do is I'm going to look at the y's, and I want to get a number that will be opposite. So I have to think about what number do 2 and 3 both go into. 2 and 3 both go into 6. So I could change the top so it's positive 6. So to do that, I'd multiply the top equation by 3. And the goal to get the bottom is to be a negative 6. So I'm going to have to multiply this by 2. So in this case, I have to multiply both equations. So the top equation is going to turn into 12x plus 6y equals 42, because I multiplied all three terms by 3. Now I'm going to multiply all three terms by 2. It's going to be 14x minus 6y equals negative 16. If I add these up, I get 26 equals 42 minus 16 is 26. Oops, I forgot the x. So this is going to be x equals 1. So now that I get x equals 1, I can use x equals 1 and substitute it into either equation. It doesn't matter. I'm just going to pick the top one. So it's going to be 4 times 1 plus 2y equals 14. So subtract 4 from each side. 2y equals 10, y equals 5. So my ordered pair is going to be 1, 5. And then number 2, or actually this should be 4. Number 4, if I add these up, I don't get them to eliminate, so I need these to be opposites. So I can choose to eliminate the x or the y. I'm going to eliminate the x. So I want these two numbers to be opposite. So I think of numbers that 5 and 4 both go into. So they both go into 20. So I'm going to make one be a positive 20. So I'm going to multiply the top equation by 4. And then I'm going to multiply the bottom equation by negative 5. Therefore, one's going to be positive 20 and the other one's going to be negative 20. So I'm going to do 20x minus 12y equals 62 times 4, which is 248. And it'll be negative 20x, I'm doing the bottom equation, minus 2y, 25y, equals 17 times 5, so 85. So it's really important that you stay organized throughout this. So the x's will cancel out, I'm going to add these two up. It's negative 37y. And I'm going to add up 248 plus 85. I get 333. Divide that by negative 37, and I get negative 9. So y is negative 9. So then you can pick either x or y to substitute in. So I'm going to plug in, first or second equation. So I'm going to plug in negative 9 to the first equation. So it's going to be 5x plus 27 equals 62. So I do 62 minus 27. And I get 5x equals 35, so x equals 7. So my ordered pair is going to be 7, negative 9. Now I'm just going to set up these word problems, and you can solve the rest on your own. So I just want to show how to set them up. So what I do with these word problems, I go to the very end and look at the variables. So it reads how many adult and student tickets were sold. So that tells me if I have two variables I'm trying to solve for, I need to have two equations, a system of two equations. It should be sells. So suppose your community center sells a total of 292 tickets. So if you sell a total of 292 tickets, that means the number of adults plus students are going have to be 292. Then an adult ticket costs $3 and a student ticket costs $1. The total ticket sales were $4.70. So if it costs $3 per adult plus $1 per student, the total money is $4.70. So you have a money equation, and then you have the number of people equation. And then you could solve this by elimination, because they're both in standard form, or you could use substitution. And then number 2, students are wrapping gifts for the holidays. They charge $4 per gift bag and $10 per wrap package. The class sells 205 gifts in all and receives a total of $10.84. How many gift bags and wrap packages did they sell? So this would be my variables: gift bags, wrap packages. So if they sell 205 gifts total, you have gift bags and wrap packages. So gift bags plus wrapped packages equals 205. And then you're going to have an equation that's relating money. So $10 a wrap package plus $4 a gift bag equals the money, which is $10.84. And you can solve by elimination or substitution.